This video is video 8.2 and this video will be based on graphing results. And in particular, we're going to look at line graphs. Line graphs are a fundamental tool in the world of data visualization, and they're widely used across various fields, not just science, but also in economics or perhaps maybe even in social sciences. They're essential for representing trends, patterns, and relationships within data sets. Within this chapter, you're going to be looking at various data sets, and drawing line graph basically involves plotting points on a Cartesian plane, which you would be quite familiar with from maths, and connecting them with what we refer to as the line of best fit to illustrate the progression of the data over time or other continuous variables. Understanding how to draw graphs is really important for several reasons. Firstly, line graphs provide a clear visual representation of the data trends. It makes complex information more accessible and understandable to the audience. By visualizing data points on a graph, you can notice patterns and fluctuations really easily. So that helps in analysing and making decisions or conclusions on particular experiments. Secondly, line graphs facilitate comparison between different sets of data. By plotting multiple lines on the same graph, you can easily observe how different factors interact and influence each other. You will see this when you're completing activity 8.12, which is investigating the effect of different catalysts on the decomposition of hydrogen peroxide. Finally, line graphs are effective in communicating findings to a diverse audience. So for example, if in science you are presenting research findings or scientific data that you've obtained, it's a concise and intuitive way to convey the information. Their simplicity and versatility makes them a preferred choice for most reports, presentations, and various papers that you might have in science too. When drawing line graphs, I use the following line graph checklist. You can see in front of you here, we have scales, we have points, we have labels, we've axes, we've titles, and we've units. And what I like to do is I like to refer to this as Splat 2. And Splat 2 is what you will use, hopefully, when you're drawing your graphs to make sure you've everything you need included. In this particular video, I'm going to go through plotting the data in the table on the left-hand side of the screen. The data that I've collected will be quite similar to the data you will collect when completing activity 8.1, which is calculating the average and instantaneous rate of reaction when you are looking at the decomposition of hydrogen peroxide using manganese dioxide as a catalyst. However, instead of recording the volume of oxygen gas produced every 30 seconds, like you will do in activity 8.1, I recorded the volume of oxygen gas produced every 10 seconds. When drawing a graph, it's important that you draw the graph on graph paper. Your teacher should be able to supply you with graph paper, or you could use the type of paper found in your maths copy. As you can see here, I have graph paper in front of me. I've included the table from the previous page, and I've also included the graph checklist. Every time I draw a graph, I like to start by writing my title on the top of the graph paper. In this particular experiment, I recorded the volume of gas produced every 10 seconds. For the title, I'm going to write the volume of oxygen gas produced over time. Once I've got the title written, the next step is I need to draw my X and my Y axes. It's important that you draw your X and your Y axes using a ruler. It's also important that you give a little space beside the X and Y axis so you're able to write the units and the values that are on the X and Y axis. Therefore, I think it's important that when you're drawing the X and Y axis, you don't draw it at the edge of the paper. So for example, here, I wouldn't draw the Y axis along this line. I might draw it along the line that's 2 in from that. The same with the X axis. I wouldn't draw the X axis here. I'd draw 2 up from the very bottom. Using your ruler, I would come up 2 boxes and come in 2 boxes and draw a line across like so. Then I would label that line X. Then I would do the very same thing for the Y-axis. So come in 2 boxes and come up 2 boxes and draw a line up the page as I'm demonstrating now. Remember to label this Y. Once the X and Y axes are drawn, I would then label the X and Y axes. You should remember from junior cycle that when drawing graphs, the dependent variable is on the y-axis and the independent variable is on the x-axis. The independent variable is what we control. In this particular experiment, we control the amount of time, or In other words, every 10 seconds I decided to record the volume of oxygen gas, so I was in control of the time. Underneath the x-axis, I will write time, and I'll also include the units. And in here, I recorded the volume every 10 seconds, so it's in seconds. On the y-axis, we place volume of oxygen gas produced, and ensure to include the units too, which is milliliters. When we have the labels of the x and the y-axes written, we need to include our scales. To begin, I'm going to put in the scale on the x-axis. On the x-axis, I recorded the time every 10 seconds, and the max amount of time I had was 100 seconds. What I need to do then is go along the x-axis and count how many boxes that I have. In total, I have 26 boxes from the start of the x-axis over this side to the end of the x-axis over this side. What I'm going to do is for every 10 seconds, I'm going to have 2 boxes. So I place little dashes where my time is going to be placed, and I write the time underneath it. So this is 10, this is 20, this is 30, we'll have 40, 50, 60, 70, 80, 90, 100. And we include all of that on the axis below. You don't need to include the units, as below you can see that we've written time, and beside time we've written in brackets S. And that is telling us that all of the values that are on the x-axis are in seconds. The y-axis is a little bit more complicated. They don't come as evenly dispersed, and the max is 11.5. On the y-axis, we have 28 boxes moving upwards. Although it only goes up to 11.5, I'm going to round that to the nearest whole number, which is above 11, which is 12. So I need 12 equally spaced spaces on the y-axis. So for every 2 boxes, I'm going to have that as 1 milliliter. So here, I'm going to have that this is 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I'm going to write those values in, but again, remember, you don't need to include the units beside it. The reason why you don't need to include the units is because on the left hand side you can see that I've written volume of oxygen gas produced, and I've put ml in brackets, and that ml means that all of the values that are on the y-axis are in milliliters. Now that we've got the labels on the x and the y-axis, and that we've got the scales on the x and y-axis too, we can go and plot our points. To plot our points, we take the 2 corresponding values from the table. In particular, we start with the first one in time is 0, and the corresponding volume of gas is 0. So to do that, I go to point 0, 0 on the graph, and I pop it in a little dot on that there. I'd advise you to plot the points using a different coloured pen. So for example, green or red. The reason why you should do this is it will make it easy to notice all of the points once they're plotted, and that will make it easy for you to draw the line of best fit later in the video. The second point is 10, 2. So I go across to 10 seconds and up to 2 seconds. At 20 seconds, we had 4. So I go across to 20 and up to 4. The third one, 30, we had 6. So I go across to 30 and up to 6. At 40 seconds, we had 8 milliliters. So I go across to 40 and up to 8. At 50, we had 9. So I go across to 50 and up to 9. At 60, we had 10. So I go across to 60 seconds and up to 10. At 70, we had 10.5. So I go across to 70 seconds and up to 10.5 milliliters. At 80, we had 11. So I go across to 80 seconds and up to 11. At 90, I had 11.2. So I go across to 90 seconds and I go up to approximately where I think 11.2 is, which is about there. And then for 100, we had 11.5 milliliters. So I go across to 100 on the x-axis and I go up to 11.5 on the y-axis. The last thing we need to do is draw our line of best fit. The line of best fit, which can also be known as a trend line or a regression line, is a line that best represents the overall trend or relationship that's observed in a scatter plot or data points like we have here. In this particular graph, there doesn't seem to be any outliers or mistakes made. So what we can do is, starting at 0, is connect the points like so, showing off the trend that's happening in this experiment. Finally, the last thing we do is we check our line graph checklist. I use Splatu to help me decide if I've everything in my graph complete. And looking at Splatu, the first thing is scales. And we've included the scales on the X and Y axis, so I can pop a little tick beside the scales. I've plotted all my points, and all my points are noticeable as I did them in red. We have included our labels on the X and Y axis. We've also drawn our X and Y axis, so I can give that a tick too. We've included our title, and we've also included the units beside the labels that we have on the X and Y axis. So in terms of what I have here, I've included all the points on Splatu, and I've also included the line of best fit for the data that we have in this experiment. From watching this video, you should be able to draw a line graph for all of the data that you will collect throughout this chapter.